Ever wondered how our understanding of the universe has evolved from the ancient times to the present day? Let's cast our minds back, way back, to the birth of science in ancient civilizations, where our journey of discovery began. In those times, the Greeks were the catalysts of change. They brought forth a philosophy called naturalism, a radical idea that proposed everything in the world, from the stars above to the earth beneath, could be explained by natural causes. This was a revolutionary thought, as it defied the common belief of attributing everything to the divine. Among the Greeks, there were a few who rose above the rest, their ideas shaping the path of scientific thought. One such figure was Aristotle, a man whose intellect and curiosity knew no bounds. He sought to explain the world around him, not through myths, but through observation and reasoning. His work in biology, zoology, physics, and many more fields left an indelible mark on the scientific world. Then there was Pythagoras, a man known to most of us for his theorem in geometry. But his contributions to science go far beyond that. He believed that at the heart of everything, there was a mathematical order. This idea, though seemingly simple, was profound. It suggested that the universe was not a chaotic mess, but a beautifully ordered entity, which could be understood through numbers. These ancient philosophers, with their insatiable curiosity and their bold ideas, were the pioneers of a new way of thinking. They dared to question, to explore, to seek answers. They did not merely accept the world as it was presented to them, but sought to understand it, to unravel its mysteries. And in doing so, they laid the groundwork for future generations. They started a spark that would grow into the roaring flame of scientific inquiry, lighting the way for centuries of discovery and progress. Ancient philosophers, curious about the world, laid the foundation for a scientific approach to understanding the universe. As civilizations rose and fell, the flame of scientific inquiry continued to burn. As we journey into the Middle Ages, we find a period often misunderstood as a dark age in scientific discovery. Yet, this era was anything but dark for the sciences. During this time, Europe was a patchwork of kingdoms and principalities, where scholars and monks working in monastic libraries and scriptoria painstakingly preserved ancient texts. They translated works of Greek and Roman philosophers, mathematicians, and physicians, keeping the embers of knowledge glowing. Meanwhile, in the Islamic world, a remarkable scientific renaissance was underway. Scholars like Ibn Sina, known in the West as Avicenna, were making significant strides in medicine, astronomy, and philosophy. Avicenna's Canon of Medicine, an encyclopedic text, became a cornerstone of medical teaching in Europe for centuries. Parallel to these advancements, the era saw the rise of a fascinating discipline, alchemy. Often dismissed as primitive chemistry or misguided mysticism, alchemy was an intricate blend of philosophy, metallurgy, and protochemistry. Alchemists aimed to transmute base metals into gold, and in their attempts they developed laboratory techniques still used today, like distillation and sublimation. In the West, the English philosopher and Franciscan friar Roger Bacon stands out. He studied alchemy and optics and is often credited with formulating an early version of the scientific method. His work, Opus Majus, advocated for the use of experimentation to verify theories, a concept that has become the bedrock of modern science. So, as we can see, the Middle Ages were not a dormant period in the history of science. They were, in fact, a time of preservation and progress. From the Islamic Golden Age to the laboratories of alchemists and the scriptoria of European monasteries, knowledge was being collected, translated, and expanded upon. It was an era that laid the foundation for the scientific revolution that was to come. Despite many misconceptions, the Middle Ages were a time of important scientific advancements. So, let's continue our journey forward into the bright dawn of the Renaissance and the birth of modern science. The Renaissance, a period of rebirth and rediscovery, also heralded the advent of modern science. This era, stretching from the 14th to the 17th century, saw an explosion of new ideas and knowledge that drastically reshaped our understanding of the world. In the heart of this intellectual revolution was a shift from relying on ancient texts and religious doctrine to embracing observation, experimentation, and critical thinking. This was a transformative time when the foundations of modern science were laid, with key figures leading the charge. Consider Nicholas Copernicus, a Polish astronomer who dared to challenge the geocentric model of the universe, a belief that had been deeply ingrained for over 1,000 years. Instead, Copernicus proposed a heliocentric model, placing the sun at the center of the universe, with Earth and other planets orbiting around it. This was a radical, even dangerous idea at the time, but it set the stage for a more accurate understanding of our place in the cosmos. Then there was Galileo Galilei, an Italian polymath who is often referred to as the father of observational astronomy, the father of modern physics, and even the father of science. Galileo made significant advancements in the study of motion and strength of materials. He also improved the telescope, allowing him to observe celestial bodies more clearly. His observations, such as the moons of Jupiter and the phases of Venus, provided substantial support for the Copernican heliocentric model. These are just a couple of the many pioneers of the Renaissance who dared to question accepted wisdom and seek out new truths. Their work, and the work of their contemporaries, marked a significant departure from the mystical and philosophical leanings of the Middle Ages, leading us towards a new era of empirical and experimental science. The Renaissance was a turning point in science, pushing humanity towards a more empirical and experimental understanding of the world. The Age of Enlightenment, a time of reason and logic, brought forth a new wave of scientific thinkers. Shining through the 17th and 18th centuries, this era was a beacon of intellectual and philosophical exploration. At the heart of this period was a profound shift in how we perceived and interacted with the natural world. Science took center stage, with new theories and methodologies challenging age-old dogmas. One of the most significant contributors was Sir Isaac Newton. His groundbreaking laws of motion and universal gravitation revolutionized our understanding of the physical world. Newton's first law, the principle of inertia, declared that an object at rest stays at rest, and an object in motion stays in motion unless acted upon by an external force. The second law connected force, mass, and acceleration in a single equation. And the third law stated that for every action, there is an equal and opposite reaction. These laws laid the foundation for classical physics, playing a pivotal role in subsequent technological advancements. But the Age of Enlightenment was not only about discoveries, it was also about methodology. During this period, the scientific method was firmly established as the backbone of scientific investigation. This process of observation, hypothesis, experimentation, and conclusion became the standard for conducting scientific research. It was a method that demanded evidence and encouraged skepticism, replacing speculation with empirical evidence. The Enlightenment brought about an era where beliefs were no longer accepted at face value. Instead, they were put to the test, examined under the microscope of reason and empirical evidence. From the laws governing the heavens to the workings of the human body, every domain of knowledge was scrutinized and studied with an unquenchable thirst for understanding. The Enlightenment solidified science as a discipline of rigorous experimentation and logical reasoning. It was an era that forever changed how we perceive the world, laying the groundwork for the scientific advancements we continue to build upon today. The 20th century and beyond has been a time of rapid scientific discovery, forever changing our understanding of the universe. This era has been marked by significant breakthroughs that have not only revolutionized science, but also significantly influenced our daily lives. One of the most groundbreaking theories of the 20th century was quantum mechanics. This theory describes nature at the smallest scales of energy levels, of atoms and subatomic particles, challenging our perceptions of the physical world and introducing the idea of uncertainty at the heart of reality. Then came the theory of relativity, proposed by Albert Einstein. This theory fundamentally changed our understanding of space, time, and gravity, and led to the prediction of phenomena such as black holes and time dilation. It was a leap that took us from a Newtonian worldview to a universe of bending space-time. Another major breakthrough was the discovery of the structure of DNA in the mid-20th century by James Watson and Francis Crick. This discovery unlocked the secrets of genetics, paving the way for advancements in biology and medicine, including genetic engineering and personalized medicine. As we moved into the 21st century, the impact of technology on scientific discovery became increasingly apparent. The advent of powerful computers and the internet has enabled scientists to process vast amounts of data and collaborate in ways that were unimaginable in the past. From mapping the human genome to detecting gravitational waves, technology has played a crucial role in driving scientific progress. Today, we stand on the shoulders of these scientific giants, reaping the benefits of their discoveries. Yet the pursuit of knowledge is unending. With the advent of technologies like artificial intelligence and quantum computing, we are pushing the boundaries of what is possible in science. The pace of scientific discovery is accelerating, propelling us into an exciting future of unknown possibilities. As we look towards the future, one can only wonder what scientific advancements await us. Imagine a world where artificial intelligence becomes an intimate part of our daily lives, not just smart assistants that answer our queries, but intelligent systems that understand our emotions, predict our needs, and even help us make decisions. This is not a distant reality, but a future that science is actively shaping. Picture this: you're unwell, and instead of heading to the doctor, you consult your personal AI. It reads your symptoms, cross-references your genetic data, and prescribes a personalized treatment. No queues, no generic medicines, just tailored healthcare at your fingertips. That's the power of AI combined with genetic engineering, and it's just the beginning. Speaking of genetic engineering, let's talk about its potential. Imagine crops that require less water, yet yield more produce. Picture animals engineered to be resistant to diseases, ensuring food security. Envision humans with enhanced immunity, reducing our vulnerability to diseases. This isn't science fiction anymore. It's a future that's unfolding thanks to science. Now, let's take a leap and venture into outer space. Mars is just the first stop in our cosmic journey. The moon is becoming a launch pad, a stepping stone for further space exploration. We're inching closer to unlocking the mysteries of the cosmos, and who knows, we might even discover life beyond Earth. But with these advancements comes a responsibility. Scientific literacy, the understanding and appreciation of scientific concepts, is more important than ever. It's what allows us to make informed decisions, to question, to innovate. It's what keeps science moving forward. The future is an exciting canvas, and science is the brush with which we're painting it. It's a time of discovery, of pushing boundaries, of challenging what we know. It's a time where the impossible becomes possible, where questions become discoveries, and where mysteries become understanding. The future of science is a fascinating mystery, one that promises to continue our journey of discovery and understanding. So what have we learned about the evolution of science? We embarked on a journey through time, tracing the footsteps of our ancestors, starting from the dawn of inquiry in ancient Greece. We witnessed how the passionate thinkers of this era laid the groundwork for the scientific method, opting for logic and reason over mythology and superstition. This period marked the birth of science as we know it, a testament to the human mind's insatiable curiosity. Then, we moved on to the Middle Ages, where the rise of alchemy bridged the gap between magic and science. This was an era of transformation, both literally and metaphorically. Alchemists, with their ambitious goals of transmuting base metals into gold and seeking the elixir of life, pushed the boundaries of knowledge. Our journey continued through the Renaissance, a period of reawakening and the birth of modern science. This era saw the fusion of science and art, leading to revolutionary discoveries in various fields. Names like Leonardo da Vinci and Galileo Galilei echoed through the halls of history, their contributions propelling humanity into a new age of understanding. Soon we found ourselves in the Age of Enlightenment, where science took center stage. The scientific method was refined and the pursuit of knowledge became a widespread endeavor. This was the age of Newton and Descartes, an era of logic, reason, and empirical evidence. Then we delved into the 20th century and beyond, an era of unprecedented scientific advancements. We witnessed the power of science to both create and destroy, from the discovery of antibiotics to the development of nuclear weapons. It was an age of exploration and innovation, propelling us into the cosmos and deep into the building blocks of life itself. Looking ahead, we explored the potential future of scientific discovery. We pondered on the possibilities of quantum computing, genetic modification, and the exploration of extraterrestrial life. These future frontiers of science, though daunting, hold immense potential for furthering our understanding of the universe. In the grand scheme of things, we've come to realize that science is not a static entity, but an ever-evolving field, shaped by the curiosity and tenacity of countless individuals across centuries. It's a testament to the human spirit, our unyielding quest for knowledge, and our capacity to question, discover, and innovate. The evolution of science is a testament to human curiosity and our relentless pursuit of understanding. As we move forward, who knows what secrets of the universe we will uncover next?